In this video, we're going to explore how different effects sound, but then also how they affect the audio waveform. Now we're going to jump right in it. We've got a lot of effects to cover. First up, we're going to talk about is distortion or overdrive. So right here, I have an example of a simple sine wave, and what we can do in a circuit is make it louder and amplify it. But with any sort of system, actual real-world speaker system, circuit system, there's a limit to how much you can amplify it before it overloads that system and begins to distort. So in the dotted green line here, I have an example of what we would call clean headroom, meaning any signal that in this circuit or speaker that wiggles between those two green lines will stay clean and not distort. But as soon as it goes past those ones, it reaches the limit of the system and begins to distort. Now, when it does so, it doesn't do so like a sine wave. It begins to change shape, and I'll explain how that works. And I apologize for a little bit of errors in my graph. I had to fix this because it's not super easy to graph. So basically what happens is, just like over here, it starts up normally, but as soon as it passes that threshold, it doesn't come back down immediately, because if it's a speaker, that speaker is moving. It's not going to freeze in place. Or if it's a circuit, the circuit that turns on to clip it doesn't do it instantaneously. It takes some time. So it actually goes up unaltered. Then as that system that is going to distort it and limit it turns on, it clips that waveform and it starts to come down. The original signal would have been something like this. So you can see that it starts to clamp in, and as soon as it passes that threshold, it holds it at that threshold until it passes back down, until the signal passes back down. And same thing over here on this other side. So let me draw in what the original signal would have looked like, amplified like so. And so it wants to go down here, but it's going to kick in to clamp it, and then when it gets here, it's going to hold it, and so on. And when it does so, by doing that, it creates a new type of waveform. This is no longer a sine wave. It has a similar waveform as ones that are more complex, meaning ones that contain more than one tone. When you hear an overdrive or distortion effect done well, it actually gives more complexity to the audio signal that sounds more interesting and full because of these sort of added little bumps that create these harmonic overtones. Here's a simple E note. It's not a pure sine wave, as no real-world instruments just simply do, but it is definitely smooth and has properties of a sine wave. And if I click on an overdrive effect, you'll immediately see that spike followed by a horizontal section, and then back down to the next spike, and so on, just as our graph had shown. There are a couple other effects that are related to this overdriven sound, but they're just amplified even further and distorted even further. And those are typically categorized as either a distortion or a fuzz. Now let's hear those now. Clean again. Distortion. Clean. Fuzz. Next, we're going to look at what happens when the pitch changes. So if this is our original sound, then if we look down here, this would be a pitch shifted down, where the period got wider, so the frequency got lower, and this would be pitch shifted up, so it repeats itself much more frequently, and so the period shrinks and the frequency we hear will go up. And you can also see that you can actually pitch modulate, where you start with the regular signal, but then you make it just a little bit longer, and then eventually you make it just a little bit shorter. And by doing so, you can make the pitch shift down and up, and we'll hear those effects in action. The original signal shifted down. The original signal again shifted up. In this clip, you'll hear the pitch shifted down and then back up rather rapidly, and by expanding and then contracting the wave, what you'll actually see is this sort of wiggle in the wave as it gets longer and then shorter again. The original signal. Pitch modulated signal. In these next modulated effects, we'll look at what happened when the phase shifts back and forth or when the amplitude shifts back and forth. So first, let's go ahead and take a look. This black dotted line is the original signal, and the blue line is one that's been phase shifted. Either you can imagine it shifting to the right, or you can think of it as shifting even further to the left. And what will happen is that if you mix these two signals together, when if the blue one shifts this way and the peaks line up with peaks and valleys line up with valleys, and you blend them together, those peaks will add to their peaks and make it even louder there, and the valleys will add to the valleys, making it louder there as well. So if they line up, it gets louder, but if you shift it where the peak of the blue one matches with the valley, the bottom of the black one, that peak and that valley, when you add them, they will add up to 0 and you won't hear it at all. And this is called phase cancellation. And so we can actually take this original signal and shift it backwards and forwards in time, mix it with the original signal, and there'll be some frequencies that get boosted and other ones that get cut. Another thing that will be happening when you phase shift something backwards and forwards, in order to do that, you essentially have to make the signal longer at one point and then shorter at another to catch it back up. And so you will hear a pitch modulated sound in addition to this phase shifting frequency change. With just a simple signal here, you'll actually only hear a tremolo effect. If it's really simple and you cancel, when you cancel the volume goes away, and when you add up it increases. We'll hear it both ways, hearing phase shifting creating a tremolo sound, and we'll hear it in its more full effect. In this first example, I'm going to play a simple harmonic, and because it's a single tone, when I turn on the phase shifted sound, it's going to add up and then cancel, making it louder and then quieter. Here's the original tone. Here's it with the phase shifter mixed in. And as I said before, musical instruments are more complex than a single wave. So as you shift the phase of the whole instrument, you actually boost some frequencies and cut some others, and it sounds much more interesting. The original signal. Phaser added in. The next effect is an EQ or a filter. Now this effect essentially amplifies certain frequencies while cutting other frequencies. For an EQ, this effect is static. It does not change. But many filters are movable and change with the playing of the instrument. Let's hear that in action. With this EQ, I've taken away the higher frequencies in the note to leave the larger low frequency waveform. This will take some of the complexities out and just leave the large sine wave low frequency note. Here's that original note with all its complexities. Here's it with the EQ on. In this clip, I've lowered the EQ on the lower part of the note, but amplified the higher frequencies. You'll hear and see that that low frequency wave is gone, and left is the shorter, higher frequencies. Here's that original note with a high EQ. This effect is called an Ottawa, which is an EQ that amplifies higher frequencies more the harder I play. The last two effects I'll do examples for are called delay and reverb. The first is a simple echo. You play a note, it records it, and then plays it back later in time, repeating like as if you were in a canyon, yelling, hello, 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 hello. The second effect is called reverb, which is short for reverberation, which talks about the fact that when you're in an enclosed space with hard walls and the sound reflects off of different walls at different times and then bounces off all of the other walls and creates this trail of sound, that is a sound that we are recreating with the reverb effect. The original signal, now with delay. The original signal, now with reverb. There are many other effects we could have gone over, but this should hopefully give you a taste of the different types of effects and their general categories that they fall under. Please join me in the live webinar where I'll help you with your specific sound as we navigate this project together. See you then.